Hello students, നമ്മൾ ഇന്ന് ചെയ്യാൻ പോണത് signed curvature of a plane curve essentially determines the curve. That is our objective. So I will just write it. Objective of today's class is signed curvature essentially determines the curve. Determines a plane curve. So what is meant by essentially? That we will specify later. Before that, we need to do a few things. Recall, in the last class we proved if gamma is a unit speed curve, then gamma of t can be written as gamma dot t. Velocity can be written as cos phi t sin phi t for some smooth function phi from alpha beta to r. So what is alpha beta? Alpha beta is the interval over which gamma is defined. Gamma is from alpha beta to r2, the parameter interval of gamma. And this phi is called the turning angle. This phi is called turning angle, and it is the angle between the unit tangent vector t and the positive x-axis. So this is the plane, this is x-axis, positive direction, this is y-axis, and suppose that this is the path of the curve. Suppose that this is the point gamma of t and gamma dot t. Since gamma is a unit speed curve, gamma dot t is a unit vector, so this is gamma dot t, which we call vector t, the unit tangent vector, and the angle the vector t makes with the positive x-axis, that is your phi. And this is a function of t, because you take another point gamma of t here, then at this point you have another unit tangent vector like this, and the angle phi is now this. So phi changes from point to point. So this phi, we proved that it's a smooth function from alpha comma beta to r, and it's called the turning angle. And now we are going to prove a corollary to this result. So it says that what is the relation between this phi and the signed curvature? Corollary says that the signed curvature kappa s is the rate of change of this signed curvature dphi by ds. S is arc length. Here also better I should write s instead of t. We can think of s as arc length. So how do we prove this? Proof. from this equation you have vector t is equal to cos phi t or cos phi s sin phi s okay. Now recall what is signed curvature. How did we define it? Suppose that this is the path of the curve, and at this point you have the unit tangent vector t, and rotate this unit tangent vector t through an angle pi by 2 counterclockwise. So you will get this vector. Call it vector n suffix s. So what are the coordinates of ns? T is this, and ns is perpendicular to t. So to obtain ns, what we are supposed to do? Interchange these two coordinates and put a minus sign in the first coordinate. So first let me interchange sin phi of s comma cos phi of s and put a minus sign in the first place. So that is this vector. The thing is that if this is the vector x comma y, then I want a vector perpendicular to this obtained by rotating through an angle pi by 2 counterclockwise. So what are the coordinates of this vector? It is precisely y comma x with a minus sign in the first place. Okay. This is ns. Let us compute t dot. Let us compute t dot. That means dt by ds. Dot represents differentiation with respect to s. So dt by ds. So what you will get? What was t? Vector t was cos phi of s comma sin phi of s. So differentiate. So what you will get? Derivative of cosine is minus sin phi of s into phi dot of s. So phi dot, let me write here, comma, now you have to differentiate sin. So derivative is cos phi of s into phi dot of s. Phi dot, let me write here. Okay, so I can take phi dot out. So I will get phi dot of minus sin phi comma cosine phi So now you look at ns. ns is this. T is a unit vector. So t dot is also perpendicular to t. Since t is a unit vector, its derivative t dot is perpendicular to t. So both n of ns and t dot, they are perpendicular to vector t. That means ns and t dot, they are parallel. ns and t dot, they are parallel. So t dot is a scalar multiple of ns. That is, scalar multiple is denoted by kappa s, ns, and this kappa s is known as the signed curvature. Okay, and let us substitute for t dot and ns. So t dot is here. So phi dot into minus sin phi comma cosine phi, that is equal to kappa s into what is vector ns. Vector ns was here. Yes, minus sin phi s cos phi s. So minus sin phi comma cos phi right? So this implies when two vectors are equal, if and only if their first components are equal and second components are equal. So this will tell you that kappa s is phi dot. Phi dot means dphi by ds. And this is what I wanted to prove. Yes. Thank you.